everyone, welcome to my channel. As always, I am going to solve one Leetcode problem today. Today's problem is number 226, Invert Binary Tree from top 100 like question. So yeah, let's take a look. Give me the root of the binary tree, invert the tree, and return its root. Alright, simple question. So given the tree like 4, 2, 7, 1, 3, 6, 9, you need to return 4, 7, 2, 9, 6, 3, 1. 4, 7, 2, 9, 6, 3, 1. So so 4, 2, 7 would be 4, 7, 2, and 7, 6, 9 would be 7, 9, 6. So it looked like the node is being flipped. The children node is being flipped. So 4, 2, 7, 4, 7, 2. 2, 1, 1, 3 is going to be 3, 1. And then 6, 9 will be 9, 6. So yeah, it seems like the node is being flipped every time. So we can just simply iterate through. So when we encounter the root, we're just going to flip the children, swap the children node, and then we go further down. And then we gonna reference to the children and swap them, and then we go further down and so on and so forth. I believe that's a solution. Okay, it'll be a really short video in that case. So yeah, since it is a pretty simple question, I'm probably gonna just start coding right away. So since this is going to be a recursive call, we want to no constraint, right? Well, there's constraint anyway. So since this is going to be recursive call, I need to have a termination call, right? The condition to stop the recursive call, otherwise it will be Stack Overflow. So that would be root is equal to null. In that case, we need to return null. And then otherwise, we want to swap the node. So tree node left would be, so swapping the node is same as swapping the variable. So we need to temporarily store the variable somewhere. So that's what I'm doing here. And do that, and then the place where the root dot left needs to be on the root dot right, and the root dot right node needs to be at the place of root dot left. So do root dot right. Now we lost the reference of the root dot left, but we still kept it in the temporarily variable called left. So that's what I'm doing right there. And after swapping the node, we can just call the children further down the root, right? Then return the root, I believe, right? So here the termination condition, when we encounter null node, let's say we go further down, swap then, and we go further down, it will be 3, right? After swapping it. And then 3 don't have children, so it will call invert tree, and then no reference. So it will terminate and come back here, terminate, it will come back here, and then come back here, and then so on and so forth. So that termination condition should be right. And then this is a simple swap logic right here, swapping the node because inverting the tree, we need to swap the node. And return the node. So the question is asking that we need to return the roots, its roots. So as the top of the call, the stack, recursive stack, the root node will be returned if I do this. And here it will return 2, and here it will return 4. 7 here, 9, 6, so on. So at the point where the recursive stack is at the first call, then it will return 4. So it will meet the condition to return its root. Let's try it out. Hopefully it's right. It's a pretty simple question. Okay, seems like it's right. Memory usage is concerning. So I guess we can solve it iteratively. Can we? Is that going to solve the problem that much though? Yeah, so memory usage is pretty bad. Because it's a recursive call, we need to use how much amount? We need to call the height of the binary tree, right? The maximum height of the binary tree, because a call stack is called like 4 will call 2, 2 will call 1, stack dot pop, and then 2 will call 3, stack dot pop, like a recursive stack, recursive call. Um, so it will be the height of the tree, I believe. In the worst case, it will be of n, where tree is just vertical. Okay, so is that possible to make it? I don't think it is. Yeah, so okay, since this is a really short video, I can just move on to maybe iterative solution. Yeah, let's try to do that. So we can, so probably we can use stack on this question when we want to solve it iteratively. Let's think about it. Let's see. So when we encounter 4, we swap the node and then put it into the stack. Children, I need to put it into the stack. So 7 and 2 will be in the stack. And then the loop will continue. We're gonna pop from the stack, and then 7 will be here, and then swap the node, and then we're gonna, after swapping the node, I want to store 9 and 6. And then it will call 9, and then pop, 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 and it will, at some point, it will go 2, and then the same thing go over. So what's the termination condition? If it is null, then we don't want to pass in the node, I believe. So if it is null, then do I want to swap? Yeah, I still want to swap. Yeah. Okay, I see. But if it is null, then I don't want to push to the stack. Okay, I see. So I guess we need to use stack because we want to sort of mock the simulate this the recursive call, right? Calling using stack. So I will use stack to simulate the recursive call here. Let's see. So yeah, what I would do probably is it's pretty much the same concept as recursive function, where so we encounter 4, we're just gonna swap the node, tree node of the children, and then when after swapping it, we're gonna store these 7 and the children, in this case 7 and 2, into the stack. So now inside the stack we have 7 and 2. So loop will continue. I think I'm gonna do that in a while loop or something. Loop will continue, and then we're gonna pop the every iteration of the loop. We're gonna pop one node, tree node, from the stack. And then in that case, because we store 7 and 2, we're gonna pop 7, right? And then we're gonna reference to the children again and swap the node. After swapping the node, we're gonna store this, and then yeah, loop will continue. Since we push this node 9 and 6, now we're gonna pop it again, new iteration, and then it'll be 9. And then we're gonna do the inside the loop, so we're gonna do the same instruction over and over again, so that will continue. Yeah. And then if the children reference to the null, and in that case, I don't want to push into the stack because what's the point for doing that? So I'm not gonna do that. So that's a termination condition, imitating that. So while stack, so I need to, is it called push? Hopefully it is. So while stack is not empty, oh wow, can't type. All right. While stack is not empty, then we want to, we can just use this, well, let's avoid confusion. So this will be root, a node, and we're gonna stack that up here. And then we want to swap, we want to implement a swap functionality here. So let's see, tree node, left. Okay, let's do the same thing. Node dot left and node dot right is going to be no, node dot left is going to be node dot right, and then node dot right is going to be left, right? And then that's a swap knowledge, swap condition right here. So let's separate the logic here. Swap current root, and we're just gonna. So this is the part. It might be confusing where we are going to push the children into the stack. So tree node. No. Node dot left and node dot right. So this is like same thing as calling the its own function. It's like just calling the own function in recursive call. So yeah, that's that's good. So when we after push, so we said that we don't really want to push the null value if it is null, but so I guess in that case what we can do is if so we can like just say the same thing, right? So if node is equal to null, then we can just continue. And then yeah, this is termination condition. And then we're just gonna return root. I believe this should work. Let's see. Okay, the first question works. So when we're using stack, I really need to be careful for referencing the empty stack and then popping from the empty stack, but we're always checking here, so that should be good. So yeah, I believe it will work. Okay, yeah, it didn't really change. Not sure how to make it efficient. I usually don't care about the memory usage, but I don't know. Let's see. Alright, they're doing the exact same thing from my first answer. Recursive, def research, breadth research. Okay, yeah, there's definitely a few ways of doing it, for sure. In case of breadth research, we need to use Q, right? Yep. Okay. Okay, yeah, I guess we can't really... What does invert mean? Yeah, that part is confusing, I think. Yeah, okay, everyone's doing the same exact thing, but somehow my memory usage is bad, but I guess I don't have to care about it. Okay, yeah, so today we saw problem number 226, invert binary tree. This is really good problem because, it had a lot of liked and then fewer dislikes. And also, I believe, if I'm not wrong, inverted binary tree is pretty popular problem or a famous problem because I forgot the detail of the story, but some of the great engineer developer who create the brew command or whatever in the Mac terminal interview at Google, and I believe he got this invert binary tree question and somehow he couldn't solve it, and he failed the interview. And he was like saying something about that in Twitter, like he like created really such a great program, but he couldn't solve this simple problem, and then he got failed at the interview, which is we need to question the interview process because he failed just by not solving the problem, even though he's a great engineer. So yeah, that's a story that I know about the inverted binary tree problem. So that's why I wanted to give it a shot if I can solve it or not, and I could solve it. So that's a good start. So yeah, yeah, thank you for watching. That's pretty much it.